So I think that in the next 5 to 10 years, we will have actually a substantial portion of, may not portion, a substantial number of heavy duty trucks on the roads. And we'll actually be making headway on building out that infrastructure, right? We know it's necessary in the long term to decarbonize long haul trucking. Just economically, it must happen.
Hello everyone, welcome back to another episode of Clean Techies, the podcast. This is episode 34, and today's conversation is with Corey Stoller, the Director of Engineering at Celadyne Technologies. They are a fuel cell startup that is still perfecting their research and their technology, but to this date, they've still achieved pretty interesting breakthroughs in what they're doing, and they're very confident in the growth and the continued development of their product. I think this was a really interesting conversation for me because it was in this topic of hydrogen and fuel cells, something that I have very, very little knowledge of. At least I had even lesser knowledge of prior to this conversation. But it was really, really interesting speaking with Corey. He had a lot of interesting insight, and he was really able to, I think, explain this technology quite well for a non-engineer. So again, very fascinating topic. Really excited to be able to bring this to you. Before we do get into the show, as always, would love to make mention to our sponsors, Next Wave Partners. Next Wave Partners are experts in the talent acquisition and recruitment space across climate tech, renewables, ESG, and technology globally. So if your team is growing or you personally are looking to make a career change, please consider reaching out to Next Wave or one of their consultants directly. You can do this a couple different ways. You can go to their LinkedIn and reach out to one of the consultants in your kind of remit or area, or you can go find more information about them at next-wavepartners.com. Definitely feel free to reach out to them. I know they are also hiring internally, so feel free to reach out if recruitment is something of interest to you. So without any further delay, let's get right into the show. All right, here we go. Well, welcome to the podcast, Corey. How are you doing today?
I'm not too bad. How are you doing today?
I'm as fine as frog hair, as my dad used to say a lot growing up. So I'm excited for this show. I guess let's just get started with having you give us a bit of your background, kind of who you are and how you ended up here.
Absolutely. And to lead off, thanks for having me. So a little bit about me. I got my PhD at the University of Texas under Delia Milliron. When I was at the University of Texas, I focused my research on electron physics in nanocrystal systems. So quite a bit of a far cry from proton exchange membranes. But actually during that time, I learned a lot about essentially moving charge through materials, as well as general inorganic chemistry, as well as material science. So that's paid a lot of dividends for me actually, and kind of offers me a different voice in this ecosystem. So after leaving UT, I actually worked at Micron Technologies for about a year and a half. During that time, I really gained a lot of my product development skills, I would say. So I had a very strong fundamental science background. And then when I was at Micron, I kind of learned how you can create a 2-year plan for totally revolutionizing a product and actually bringing it to market, and all of the individual steps that might entail. So having come from Delia's group, the founder and CEO of Celadyne, Gary Ong, he also graduated out of Delia's group and we overlapped. So when he came upon funding, I reached out to him and said, hey, I want to do this with you. Let's make hydrogen happen. And so then I actually transitioned over to Celadyne. And what we do at Celadyne is actually develop new proton exchange membrane materials, as well as in the near future, we're working towards actually integrating those into standalone fuel cells. I think that more or less covers my background, so we can move on.
Yeah, I guess I'm kind of curious, what was really the impetus to get you into being in the space of kind of focusing on solving some climate change issue?
Sure. Yeah. So actually, when I was in my undergrad, I started to really become really aware, I guess, of the climate change issues that are ongoing, and kind of I guess I would say, I don't know if it's ignorance or naivety with which people at that point in time were really approaching these problems. So you'd hear a lot of people say, oh, the CO2 is a really big problem, or global temperatures are a really big problem, or ocean acidification, the list goes on and on. And there was a pretty laissez-faire attitude about it, which I didn't really fully understand until I learned chemistry and kind of developed a mind for what that really means for the livelihood of the human race. Then when I went to grad school, I really wanted to get into green energy or something in the green sphere and try to push the boundaries of that. So I was very ancillary in grad school. I touched solar a little bit in grad school, but ultimately my interest in fundamental physics kind of took over and I went a totally different direction. However, when Gary had started the company, as I was finishing grad school, I was like, this is a great opportunity. I want to get in on this. I've been pretty passionate about saving wildlife, saving the environment, and really creating a sustainable future for so many years, and just kind of haven't had an opportunity to do it. So the moment I had that opportunity, I jumped right in, and I've been pretty full force since.
Yeah, that makes sense. I feel like a lot of people I've talked to in this space did not set out with this like in mind. They didn't have a clear path on how they were going to get there, but then something kind of presented itself. Which I guess this is kind of, I typically talk about education further in the back, further at the end of the podcast. But I would be keen to understand, like, do you have any insight or thoughts in general on, as education is shifting and more people are being aware of the climate issues? I feel like I've noticed a lot of people going into different programs that are maybe ESG or environmentally focused, but the number of people going into heavy industry or these other industries that appear on the surface to be completely bad for the environment, people are just steering clear of those because the immediate future would be a job in a polluting type of company. So do you have any thoughts on just that space in general and what you're seeing and what people should maybe think about?
Yeah, I've noticed a really big shift in actually the population at large. Kind of over my, let's say, 10-year career, 12-year career now, I've kind of noticed that laissez-faire attitude of, it's tomorrow's problem, really shifting into, this young generation of millennials and Gen Z who are coming out, and they really want to tackle this problem head on. I know I felt that in myself. I'm educated in chemical engineering. It's a huge field that goes into oil and goes into gas and some of those more polluting industries, heavy chemicals. And I kind of I tussled with that myself, right? And I'm passionate about the environment. I'm passionate about making those changes, and I actually looked at that as like, well, you can solve that from the inside on one hand. On the other hand, there's something, I don't know, I guess intrinsic to me that I'm like, I want to make some like big revolutionary change. Uh, Having experienced industry, I kind of understand how those big sweeping changes are not necessarily going to happen overnight. Whereas, in 2 years at Celadyne, we've made huge strides and we've been able to push technology so far, like further than I would have expected to be able to push even in grad school with the freedom of an academic institution, because we're all passionate and we're all aligned. And I think that's my biggest takeaway of how people are changing over time is I think young people now are so passionate about whether it's the environment or cleaning up the oceans of plastic pollution, or just wanting to expand people's access to the environment, or anything human welfare based, healthcare, access to medicine, etc. All of those things I think the young generation are really pushing hard. Why that's happened, I guess, is the crux of your question. In the education standpoint, I actually am not really entirely sure what has caused that. Maybe just the increased airtime, honestly, in some part probably due to Bill Nye.
Mhm.
um, but it's been remarkable to see, and I'm super stoked about it. I really look forward to what the future holds with this generation aging up.
Yeah, I think there's a lot of interesting people that I've heard mention things on Twitter about the Gen Z's just general kind of mentality to do things on their own rather than waiting for a job to turn up. And I guess one of the things I sometimes get concerned about is that, especially being in talent for my day job, seeing a lack of input to some of these other industries that are quote unquote dying, but that could be humongous opportunities for change, right? Like when you have these big oil companies making massive changes, like you look back at the story of Orsted and Dong Energy, right? Changing and creating offshore wind, making it a viable thing, but it wouldn't have been possible without the previous capital from their previous, experience. But anyways, I guess it's just an interesting topic to touch on. Let's get back to kind of fuel cells and hydrogen in general. Could you explain? So I'm also very new at this, obviously. Walk us through what exactly is a fuel cell. What are some of the use cases, and can you just kind of explain the basics to us to a non-technical audience?
Absolutely. So at its face value, you can really imagine a fuel cell. Let's look at the hydrogen life cycle. It's essentially you take water, you split it into hydrogen and oxygen. That hydrogen gets fed into a fuel cell. It is split into single protons. Protons move through the membrane. They recombine with oxygen at the other side and create water again. So it's a closed loop system going from water to hydrogen back to water. The actual fuel cells themselves, that difference in chemical potential is actually what is creating the electricity that you're interested in harnessing. Some applications for hydrogen as power have been demonstrated in, let's say, moving things, so cars, drones, and recently there's been a very big push for heavy duty as this field has kind of matured. The additional uses of it are actually stationary. So a lot of companies actually do use stationary fuel cells as their emergency power source. So they keep some amount of hydrogen on site. They have a fuel cell that basically just sits dormant, power goes out, fuel cell clicks on, and it keeps, let's say, their cloud services running in the absence of grid. So one thing that I'm particularly interested in is the heavy duty application. I think there's, as I said, there's a lot of momentum right now of trying to push for this enabling heavy duty fuel cells. Part of the reason that that's very interesting is if you watch Twitter and you see Elon Musk tweet about hydrogen or some hydrogen supporters tweet about batteries, you get this kind of combative relationship where they're both like, no, my technology is better, my technology is better. The interesting thing is that they both kind of actually have perks in and of themselves. So what you do see in heavy duty and why hydrogen's interesting for that is about 70% of heavy duty happens in the 500 to 750 mile range. And that range is particularly a little rough for batteries because of the dwell time required for charging. So you can say, okay, batteries work very, very well for cars. They even work very well for, last mile delivery or small deliveries around a city. But in long haul trucking is really where you see hydrogen as a necessity. There's actually a pretty recent NREL report where they show that in economic systems in which that dwell time means a loss of miles moved or goods moved, fuel cells are the option in the ultimate scenario. So the DOE's goals for batteries and hydrogen fuel cells, eventually hydrogen fuel cells are simply necessary for decarbonized long haul trucking. And a lot of that is by virtue of the fact that, well, part of the DOE's target and all of the hydrogen industry's target really is when you go to fuel up your truck, it takes as long as it would take you to fuel up with diesel. So it makes this really nice time parity between what people are used to and what they're moving to. And then even besides that, the cost of ownership of a heavy duty fuel cell truck actually gains parity with diesel in the long run. So now you're in this situation where there's no green premium, as long as you're able to hit some of these technical requirements for heavy duty of membrane durability, catalyst durability, decreasing the cost of hydrogen, and having a highly efficient fuel cell. So when you're able to actually do those things, you get rid of this green premium, and you essentially are giving people the option, okay, you could, for no cost extra, go green or stick with diesel. And the pro is, well, with the hydrogen, maybe you can go longer than the diesel and it could be more convenient, or you can go with diesel. Generally speaking, studies have shown that people, given no premium cost, will go the green option. And so it's actually a very simple thing to push, right? Because once you have cost parity, it's actually very easy to convince people that they should decarbonize. So that's why I'm really excited about it. I think it's a great opportunity to decarbonize one of the most notoriously difficult industries to decarbonize.
Yeah, so let's go through a couple of these things. So I guess,
Sure.
First of all, I'm curious if you could walk us through actually, so when you have the fuel cell, is you mentioned that there's being hydrogen put into it, kind of like a fuel tank, right? And then it's going passing through the membrane, and that, how is the energy harvested that then takes it to power whatever it's powering?
Sure. So what is actually happening is, so the hydrogen is actually flowing over a platinum electrode. The platinum is splitting it into an electron and a proton, 2 of each. They move across the membrane, and the electron actually has to go through the circuit to get to the other side in order for the water formation to occur. So that's where you're generating your current, is the splitting of the hydrogen. The electron goes through, powers the motor, let's say in this case, and then continues on and forms water at the cathode. So that's does that make sense?
Yeah, so it's almost like a dam, having water run through it, kind of like it's just as it goes through, it's turning or powering whatever it's powering. In this case, a motor.
Yep.
Is that correct?
Yeah, that is a perfectly fair way of looking at what's actually happening to those electrons. They're essentially acting as water through a dam. A even more simplistic way of looking at it is, actually, you can kind of think about it as a battery. Batteries work essentially the exact same way.
Okay.
Not
Now,
hydrogen.
got it. So then with the fueling, you mentioned before, I thought you had mentioned water, and then it comes out again as water. Are we actually fueling these vehicles, for example, with hydrogen, pure hydrogen, or is it water? And from there, I have a couple other questions.
Sure. Yeah. So you're actually fueling it with hydrogen. Let's say, as an example, Shell, who has invested a lot in electrolysis to generate hydrogen, they would generate hydrogen, compress it, 7,000 psi. That is then what you would put into your vehicle. The hydrogen, the only exhaust out of your vehicle after it passes through the fuel cell, is simply water.
Okay. So then the next question would be, what is the process like to, you say what do you say it's called when they create the hydrogen and compress it?
Electrolysis is one way of doing it.
Electrolysis. So what is the process like for that? Is that extremely difficult, dangerous? I know a lot of people talk about hydrogen and they're concerned for safety. So could you talk about those concerns, and maybe, I guess I'm curious always to understand some of the history of like what has happened, what were the objections, and what do we have now? So could you walk us through that stuff?
Sure. Yeah. So the process of creating the hydrogen is mostly actually complicated because electrolyzers have a pretty small room for impurities. So the water has to be very, very pure. And so that's actually quite expensive to purify water. And then the electrolyzer is actually exactly a fuel cell in reverse. So the exact opposite is happening. So you're splitting water, creating, so water is H2O, you're creating an OH and an H. The H goes through, creates hydrogen on the other side. So it's actually kind of a beautifully elegant system in that the fuel cell and the electrolyzer are just direct mirrors of each other. So part of the issue with that is the cost of hydrogen is very strongly linked to the price of electricity. Because if you think about it, all of that electricity that you're going to use in the road, that actually must have been put into the system back to split the water. So it's an energy, making hydrogen is seen as an energy storage technique where you're putting a bunch of energy into the system to generate hydrogen. That hydrogen is effectively storing that energy. When you run it through a fuel cell, you're releasing that energy. Onto the safety concerns. So generally, one of the very nice things about hydrogen, let's say as opposed to another gas species that's used for transportation, like liquid natural gas, if there's a hydrogen leak, hypothetically, hydrogen is significantly less dense than air. So it actually, if it were to spark and catch flame, it would be flaming up and not out and around. Whereas liquid natural gas and natural gas in and of itself, when you get a fire, it actually spreads laterally across the ground. So it's significantly more dangerous. So that's one of the interesting kind of safety things about hydrogen is it's due to its very low density, it's actually relatively safe. I believe, I don't want to misquote this DOE report, but I actually believe that DOE had done safety analysis on this. Definitely showed it's safer than batteries, and I believe even safer than internal combustion engines.
Interesting.
Yeah.
Yeah, I think it's always funny, you get a lot of people who are concerned about these different things and they have their what seem to be logical arguments, right? But in reality, It's like think about the fact that your car you drive around every day could just blow up too, right? Let's focus on what we have. So that makes sense. I guess one of the things that I wanted to touch on from your previous point, when you mentioned the energy that goes into creating the hydrogen and then its output, is the output total energy greater than what it costs to create it typically, or is that what they're working on?
No, so that's, due to thermodynamics, that's actually not possible for that energy to be greater. However, electrolyzers are actually very efficient. So let me see if I can remember the exact losses. So electrolyzers are about 95% efficient. The fuel cell itself is right around 65% efficient. So running the math real quick in my head, it's roughly 59% efficiency of energy into hydrogen out onto the road.
Got it. Okay, that makes sense. So I think that pretty well covers those aspects. I guess maybe let's move on to, before we get into the specific technologies you guys are working on, let's move on next to, you talked about the infrastructure and why, when given a choice, most people would choose hydrogen. If that's the case, or the green option, why is hydrogen in heavy, hauling things not viable right now? Why is it not everywhere? What are some of the big challenges or things that need to be overcome? And you can go wild on this tangent everywhere you want.
Sure. Yeah. So the biggest issue, I'll just start with that. So this is the one that I'm currently most interested in, is the durability of the membranes. So the conventional membrane currently on the market actually has a operation lifetime of about 4,000 to 5,000 hours. And the reason for that is actually it chemically deteriorates during operation. So what we're actually working on is we've been able to develop a system, an approach to this where we can drastically improve the durability of the membrane and therefore drastically improve the lifetime of fuel cells. So there's another interesting report that actually has come out in the last 2 years or so was it's a PNAS paper where they survey 39 industry experts. So mixed from industry, government, and academics. They have a combined total of something 700 years of experience, something very large along those lines, where they actually thought that the commercially available membranes that would have a lifetime of just 8,000 hours wouldn't exist until as late as 2050. And that mirrors actually the DOE's targets. However, we actually believe that we'll be able to commercialize a membrane with 8,000 hours of durability by 2025. So we're really excited about the durability problem. Having that be the primary limiter, we actually think that we can make we can really help the industry and help enable hydrogen and heavy duty in just the next few years. Aside from that, and something else that we're also really interested in is improving the fuel efficiency of heavy duty fuel cells. So there's a myriad of ways to improve efficiency. The one that we're particularly interested in is bumping up the temperature of the fuel cell operation. That has a lot of effects, actually. So higher temperature fuel cell operation means that the total size of the fuel cell with its balance of plant, so like the radiator, compressors, water source to hydrate the membrane, all of those things can actually get smaller if you can boost the temperature. So it makes it more volumetrically efficient, and also the efficiency of the fuel cell converting hydrogen to energy is also higher. So one of the key limiters to that is actually that current membranes do need to be hydrated. So they pump water into the system and make water out of the system. Some of our technology interests are actually making membranes that operate at less humidification and therefore can operate at higher temperatures because they won't dry out like the current commercial membranes will. So we think the combination of these two approaches is paramount to enabling heavy duty. And we really believe that we're in just a few years away from actually making these things commercially available.
So is the fact that the membrane wears out, is that one of the hardest issues with getting cost parity?
That is actually a very big issue. So one of the key assumptions in that NREL report was actually that the fuel cell, all of the engines, motors, and whatever power source they were using had to survive for 1,000,000 miles. So for 1,000,000 miles is actually roughly a little over 10,000 hour durability. And that's actually our target. So we want by 2025 to be able to enable that 1,000,000 mile. And then the next hurdle is the efficiency. And the combination of those two things, assuming electrolysis also becomes cheaper, we may also go the way of electrolysis if that's not the case, but assuming electrolysis also becomes cheaper, that is what you need to achieve cost parity. So we think we can greatly accelerate this transition with these two simple advances.
Yeah, that makes sense. I was curious about that too, because if renewables continue to penetrate the grid, I mean, it would make sense that electrolysis would become cheaper. Would there be a big issue with rolling out the infrastructure for fueling? Would that be a pretty tough thing to achieve?
For fuel, yes, absolutely. So that is a big hurdle. So the interesting thing is actually there are companies currently working on this. So Navistar and GM actually are working together to create a heavy duty fuel cell truck. So a Class 8 truck that runs with a fuel cell. And they're working with, I believe, 1H2 as their fueling partner. And their plan is they're going to make some fueling stations that one can provide the hydrogen for, so they can build that infrastructure, test out the heavy duty trucks running along those predefined routes, and then expand from there. So that's generally been the approach so far of what people are expecting is you start off by building these pretty localized hydrogen networks along well-known heavy-duty shipping routes. And once you have that initial infrastructure in, you're 80% of the way to solving the problem, because you can just build off of that infrastructure to guarantee access to hydrogen for everyone.
That's actually quite interesting because it's obviously quite different than the problem of EVs, right? Because you don't know where an EV is going to go, but yet you have kind of a standardized, it's almost like trains to some extent, right? You know, there's a defined line to some extent, and you can, that's quite interesting. Okay. So that doesn't seem like it would be nearly as hard as, you know, for example, penetrating the entire EV charging market, for example.
Yeah, it's I would say the challenges are different. So once
Hmm.
that infrastructure is in place, it certainly it has a clear roadmap. The difference is, I mean, very bluntly, that hydrogen stations are more expensive than EV stations just by virtue of you're storing
Yeah.
hydrogen. Getting hydrogen places is more expensive than just tapping into the grid.
Hmm.
However, that's actually, once you have that initial infrastructure out, it's actually no more expensive than essentially changing out the gasoline infrastructure into a hydrogen infrastructure with
Hmm.
some modifications. So it does become very, very cost competitive once you get through that initial hurdle of the bones.
Hmm. Does it, I mean, does the DOE discuss whether this would be the better option for EVs as well?
Um, I'm actually not sure.
Interesting. I guess I'm always curious because I've had a lot of people I talk about Teslas to, and they're like, oh, you know, once it's hydrogen, I'll get into it, but I'm not interested in a Tesla. But anyways, okay, let's move on to, I want to learn a little bit more about what exactly is nanocoating. So could you kind of explain to us the process of how this works? Is it just like, where do you get the chemicals from? What are the baseline materials? Just kind of educate us a little bit on this and how you actually go through. I guess I just want to pair it with the idea of how you go through R&D on something like this, where you have an outcome in mind, but you obviously have to test hypotheses and like figure out when to trash things and when to keep going with it. So could you walk us through that process?
Sure. So as you had stated, yeah. So the whole idea was based off of a nano ceramic polymer composite, um, where we had actually seen some anomalously high conductivities at very, very low hydration. So this was a really, really big deal. Um, we Most of our work has actually focused on essentially trying to understand the design parameters that actually go into that. Like what dictates the performance that we actually measure? Is it something about the surface chemistry of the inorganic material, or is it the inorganic material interacting with polymers? Um, Ultimately, the real thing that comes out is like the benefit of that nanocomposite approach as a whole is, yes, the conductivity, of course, but the second aspect to it is it blocks hydrogen very well. So I kind of glossed over this because I actually thought it was getting a little too in the weeds, but now it's pertinent to talk about. The chemical degradation that the current membrane goes through is actually a result of hydrogen not splitting, but going through the membrane to the cathode, and it forms hydrogen peroxide. Hydrogen peroxide eats the membrane away. So this nanocomposite approach actually is very, very good at blocking hydrogen. Um, Roughly about 10 times better than the current membrane material is. So that is actually what really allows us to extend the durability of the membranes, because we simply form less of the etching material, the deteriorating material on the cathode side. So that's a lot of the reason that it's really exciting, because we do get this performance parity to the current membrane in terms of conduction of protons, but on top of that, we form 10% of the deleterious chemical on the cathode side. So it creates this kind of idyllic future where you have high durability and matched electrical performance. And that's a really massive leap in the field, honestly. The incumbent material that's currently used was invented in, let's say, I believe the 60s. So it is old. It's old material. And the past 40 plus years, people have been trying to make something that even matches its performance. And we feel actually we've kind of been able to significantly improve on it in a real quick burst of innovation, which is absolutely incredible. So that's kind of why it's exciting. I think why the DOE may be excited about it. Ultimately, it's a pretty revolutionary material. We're pretty excited about it.
Mhm. I guess I think we've talked about costs already. Maybe let's move on to a little bit of, I guess I'm curious. I know this might be a little bit too far in the future because you guys are focused on maybe a very specific aspect of the fuel cell, but I'm curious what role data and IoT kind of play currently in what you guys are doing and the technologies, maybe beyond what you guys are doing, but with companies who have fuel cells and manufacture them are doing, or at least if you're not implementing that into anything you do, is it something that kind of plays into your future idea of what the company will do, how we can track this data and actually continually improve from there? Because I know I've talked to some people who talked about the importance of all this lost data, right? That could be tracked and then just stored somewhere for public use that another entrepreneur might come by and fix something. Are there any kind of plays in data and IoT that you guys are looking at?
So there are no current plays, although this is actually something very interesting to me. Um, I actually just over the holiday break, I was really thinking about how interesting it would be to have a software solution to this is more on a corporate level, right? So like this would be within a company, so it's a little less grandiose, but falls along the same idea of essentially cataloging knobs that you're using in an experiment. So what are you kind of playing with? And what were the results? And actually keeping that cataloged in essentially a machine learning system where a lot of hypotheses that might get lost because I don't remember what I did 3 years ago. I can't really feed that information back in without an active effort. A lot of that information could just in the background get fed back in and not be lost to the sands of time. So it is actually a topic that I'm super interested in. And I think is at least on the small scale, is a really interesting opportunity. We have not ventured down that route,
Yeah,
but I'm very interested in that for sure.
that's a very interesting. I guess I never thought about it that way because it's essentially that innovation comes from observation of current things and how they can be improved. But like you said, if you're not observing it, or maybe you're observing it but not tracking it, you're going to lose it, right? And that's what I think a lot about. Just in our daily work lives, right? Like we could improve on the way we run our schedule, but if we don't take a step back to observe, it's a wasted opportunity. So that's interesting. I think we can move on from that, but I definitely think maybe somebody listening will be inspired and get started.
Hopefully.
Maybe could you talk a little bit? I don't know how involved you were with the process since you sounded like you joined a little bit afterwards, but what has been the process of funding and like what have investors been like? Are they really easy to reach? Are they skeptical? I'm just kind of curious to hear this from the portfolio company side, given that it seems as though there's a huge amount of money being flowing into climate tech. I'm just kind of curious what the experience has been.
Yeah. So I can speak actually on both sides. So on the grant funding side, so we do actually have quite a number of grants through the DOE, the Air Force, and the National Science Foundation. That side it's very driven by innovation, right? So the things that from what we've seen is you need to have a compelling case of why your research is why it matters and why is it innovative. And if you can kind of tick those boxes in a compelling way, government grants are there, right? They are ultimately going to the people who can answer those questions the best. So I think for us, the hydrogen economy is a very compelling story just in and of itself. So in a lot of ways, there's some advantage to being in hydrogen because of that. The DOE has high expectations for hydrogen and fuel cell technologies, and it's also very commercializable products. If you say, hey, we can multiple the durability of current fuel cells, the market's clear, right? You can write a very clear market case on that. On the science side, is your approach novel? We do feel like we have a pretty novel approach. So that's more or less been our experience. We've been relatively successful on the grant side with that understanding. And generally what I've seen in clean tech is everybody is able to make those kind of cases, and then they're very successful in the grant funding side. On the investor side, it's actually kind of interesting. So hydrogen's gone through a little bit of a renaissance period, actually, where people are really interested in investing in hydrogen. It was even reflected in the US stock market, roughly a year ago from now. The stock market for hydrogen companies boomed in 2021. And that was true also for investors. But once again, the same requirements are there. People do want you to have a good market case for why is your tech interesting. So for us, as I've kind of harped on a bunch of times now, our real play right now is, well, there's two limiters on the demand side, and it's durability and efficiency. And we believe we have the tech to fix those problems. The approach is novel. It's patented by us, so we own the IP for it, and there's a clear business case, and the economics make sense. So in addition to all of the costs that we've talked about, you also have to make sure that your product has a good techno-economic analysis. Like, you'll actually be able to sell it not at a loss, eventually, at least. And that's also a compelling case on the grant side too. I forgot to mention that depending on which agency the grant's going through, the ability to commercialize is also just totally paramount. So I mean, that would be my advice to anyone who's listening who has a young startup company in green energy, is really spend the time to run a techno-economic analysis on your material or your process or whatever you're making. Really figure out, why do people care? Why do they want it? And is your approach interesting and novel? And if you can tick those three boxes, right now is one of the best, if not the best time in the history of humanity to start a green energy company. All you have to do is tick those boxes and believe in it and have it be scientifically founded.
Yeah, I think that's quite interesting. I've noticed a lot of people out there who are extremely technically savvy and have all these ideas on how to fix things. Many are just, I guess, maybe not as familiar with the funding side. So I think that's helpful. Maybe just a couple things to wrap up here. Generally speaking, I'm always curious to know if, I know you're not going through a massive hiring spree right now or anything, but generally speaking, finding talent to work for you, how has that been? Do you feel that the universities in general are doing quite a good job of kind of preparing for this next wave of jobs? I always look at all these new industries, and it's like, 5 years ago, even probably 2 years ago, most people coming out of high school did not think or even know about these things. Therefore, they did not decide on 4 years to spend of their life, maybe 4 to 8, to go and then get educated to go work in that field. So what do you see happening there? Are there any things that you kind of would be on the lookout for?
Sure. So I will make a minor correction. We are hiring.
Oh, yeah.
We're actually doing a very large expansion of our team, so conveniently timed. But finding talent, actually, it's kind of interesting. I think in some way, we're almost spoiled by riches, where I'll get so many applicants that have these degrees in something green energy related. Maybe they're in environmental science or even civil engineering, chemical engineering, and they have an environmental focus. And it's kind of overwhelming in some ways, because it's like there's so many qualified people, and how do you decipher between them? So it's that part has been a very interesting experience. We, by virtue of the intersection of sciences that we work in with this nanocomposite approach, kind of actually our biggest struggle has been that science very rarely actually mixes. The inorganic knowledge and the polymer knowledge kind of live in bubbles from each other. So that's actually been the most interesting kind of thing that I've noticed is you get good polymer people, you get good inorganic people, and it's very rare that they actually come together, which in some ways also probably explains why this technology has gone unnoticed, because there's not a lot of opportunity given that there's not a ton of crosstalk. But so that's been my main takeaway from the experience of hiring is there's a huge amount of people, particularly at the entry level, that do have education in, I would say, general environmental knowledge and some general knowledge about fuel cells. Digging into the nitty gritty, very specific to us. We live at a weird intersection, so it's probably not representative of most green energy companies. But yeah, it's a pretty interesting time for that.
No, I think that is an interesting point, because you probably, I mean, I can't think of any specific off the top of my head, but I'm sure there's many industries that have gone through this kind of intersection, right? They are creating an intersection of industries, right? And you might have to find two really qualified people in each side and have them figure it out together and then create the new, I guess, the new discipline, for example.
Right.
So that's interesting. Do you guys do a lot of work with the universities and kind of talking to students and everything? I'm always curious to hear what the companies at the ground level innovating these things are doing.
So we do work still with University of Texas quite a bit. So we worked with Delia's group as well as Benny Freeman at UT. As far as actual outreach to the students, honestly, I have not really taken part in that terribly strongly. It's something that I am very interested in. I'm very passionate about. I mean, particularly, not to kind of silo myself, but particularly on the grad student side, because I think on the undergraduate side, there's so many programs to get people excited. Now there's like a Sierra Club or whatever kind of environmental club at every university, and you'll find it everywhere, and it's pretty popular amongst undergrads, as well as the education just generally has a pretty nice environmental focus. So you're kind of creating that passion amongst them. I do see the grad student education being a little bit like they're the forgotten people in some way, where they struggle with a lot of things. The universities generally don't have a huge incentive to do the types of things that they do with undergrads of like student life, because, well, grad students generally select their grad school for research, not for student life. And so I am actually that is something that I'm really passionate about on the education side, is really outreaching towards those grad students, showing them what kind of things they can do, where they can take their education and actually utilize it to either help the future or advance an industry, or really just find their passion. Because I mean, I know what that experience is like, and it can be very isolating. You're like, I don't know what I want to do with my life. All I do is this one research, and nobody's really there telling you like, hey, there's all this other stuff you can be doing, and all of these interesting things that are just so closely related to what you're currently doing. And I think that that's a really underserved group of people that I'm very interested in trying to help.
That does make a lot of sense. I mean, if you think about how innovation happens, right? The whole idea behind it is really that you have to go into something that's either an intersection or hasn't really been thought of, right? It's not something that stems from minor incremental, changes. It's something that's kind of a leap and a bound. So that is interesting. I think that's an interesting topic. So maybe, I guess, just to close things off, I would be keen to hear your final thoughts in general on the macro. Where do you think in 5 to 10 years that maybe the work you are doing specifically, but more broadly as well, just the hydrogen space in general will be, and kind of in the ideal world, what could it look like?
Yeah, so I think that in the next 5 to 10 years, we will have actually a substantial portion of, a substantial number of heavy duty trucks on the roads, and we'll actually be making headway on building out that infrastructure, right? We know it's necessary in the long term to decarbonize long haul trucking. Just economically, it must happen. So I think we're actually going to see a steady march of progress towards that. And that's going to be reflected in the roughly 4 to 6 current big players in vehicle markets actually moving towards heavy duty fuel cell vehicles. And so my anticipation is, let's say 5 years from now, those are actually going to be road ready. They will actually be on the road testing. And maybe another 5 years from then, it will be expanded networks of that testing. And on a slightly more granular level with the fuel cells themselves, I believe in 10 years, we will actually be able to get to the point where that 1 million mile fuel cell becomes a reality and a true expectation of what, if you're going to bring a fuel cell on the market, it must tick this box. It will become a requirement, much in the way that, as we move from hybrid to full on battery vehicles, it was the 250 miles. If you don't have 250 miles, nobody's interested in your car. I think the fuel cell is going to be, if you can't go 1 million miles, nobody's interested in your truck.
Mhm.
I think that's the long vision play of where heavy duty is moving. And I think it will start to see that as a reality in 10 years. And I do believe Celadyne will be able to play a role in that based on the advances that we're making, and why I can say quite confidently that I believe that that'll be a thing. And I think Celadyne will be a player in that market.
Very good. Well, it's an exciting time. I always love when things are changed. I know not everybody has the same tolerance for change, but I love it. I love new things. It's, growing up, I always thought about, oh, it'd be so interesting to grow up, 100 years ago when there's all these innovations happening. But then I started to realize there's always innovations happening. You just got to look in front of you. So very good. Well, thank you so much for coming on today, Corey. I really appreciate it. This has been extremely
Yeah,
educational for me and hopefully for everybody listening. And we'll have you on again in the future as you guys continue to improve the technology.
awesome. Thank you very much. Really appreciate your time again, and thanks for having me on.
Yeah, absolutely. It's my pleasure.
All right, thank you so much for listening today. Really hope you enjoyed today's episode with Corey as much as I did. It was, to me, one of the more fascinating conversations I've had in a while, given that, again, it's a completely new space for me, very, very fresh to this space. And Corey essentially introduced me to it. So I hope you enjoyed it. If you are listening on Apple Podcasts, we always appreciate a rating. And if this is your first time here and you'd like to be made aware of more podcasts in the future, please do subscribe and turn on notifications so you can kind of follow along. And then, of course, as always, we please share this episode with somebody who you think might find value in it, somebody who might be interested in it, maybe somebody who's been looking to learn about fuel cells or has maybe heard about it but doesn't actually know a lot, kind of like myself. Please do share it with somebody like that. You can consider joining our Slack channel if you want to get a little bit more engaged with a community of other professionals in the climate tech space. Again, anybody is welcome, whether you are already in the space or learning. It's definitely a very small community at the moment, but we hope for that to grow. And then you can subscribe to the newsletter, which comes out the 27th of every month, where we deep dive into typically one kind of topic area. I think last month was the circular economy, and I'm not sure exactly what we're going to be releasing this month, but tune in for that. And then you can definitely connect with Corey on LinkedIn and learn more about what they're doing on their website. And then, of course, as always, feel free to reach me on Twitter with any questions. And for next week, actually later on this week, we're going to be hearing from David at Vern Energy Solutions. So really interesting company, what they're doing. They're part of the Breakthrough Energy Ventures kind of family of different incubators and startups. And they're doing some very interesting technology on another aspect of hydrogen, which is basically the fuel tank that holds the hydrogen. From what I've now learned, this poses a very difficult engineering challenge. So we're going to be having that conversation with David, and that'll be coming out later this week. So tune in for that. We'll kind of have a 2-episode week for you here, and hopefully you enjoy that conversation as well. But other than that, I think thank you so much for listening, and we will see you next time on the podcast.